Hello all. If Welcome to our channel Where to Know. If you are a hobbyist and if you want to build a simple smart water tank alarm for your circuit, this video is for you. Okay, so in this smart water tank alarm, basically we will show how a sensor and a component like buzzer can be used to provide um, an alarm when water reaches a specific level. So if you see the specific circuit, we are using a 5 volts DC supply to power the circuit. Now again, this circuit can be used um, by you to and also use a supply as per your requirement. Like you can use a battery here, or you can use a AC to DC converter here to generate 5 volts. Whatever is the means of supply that is present, it can be used. And this is a simple circuit where there are two major elements in this circuit. One is NPN transistor, which is here, and there is another transistor which is PNP. Okay, to this PNP transistor we have a load that is connected, and this particular load which is at the emitter side of the PNP transistor is connected to the ground. Okay, so this load can be a buzzer, this load can be a LED indicator, or any other circuit, or you can use a simple relay kind of mechanism here and further control your motor turn on and off as well correspondingly. Okay, but here we have considered a simple 10 ohm speaker. Okay, you can consider it as a buzzer, and you actually have to turn on this buzzer when the water level has reached a specific height in your tank, right? So for that, what we did is we have a sensor here. Okay, this sensor is actually attached at the top level of your water tank, and whenever there is no water at that level, the resistance of this particular sensor will be very high. Now if you see here, the resistance of this particular sensor is around 1 mech. Okay, that means there is almost a negligible current that is flowing into the base of this NPN transistor, and that current won't be enough to turn on your transistor. What we mean by not enough is because the NPN transistor, BJTs especially, are current control devices, right? So when you have your sensor connected and through a supply, your base should have sufficient current to turn on, right? So in this case, your sensor is treated as if there is no water. That means sensor impedance is very high, so the current that flows into this base is less. So that means this particular transistor is in off condition. So when this particular transistor is in off condition, what happens is this pin will be floating, and correspondingly this particular transistor, whatever is there, will be in off condition. Okay, and if this is in off condition, we should see that V out should not have any supply, or this particular load should not be supplied with any voltage. Okay, let us just try to simulate this and see the scenario. Okay, now as we said, as there is a negligible current flowing and this is off, this will be floating, right? Floating meant it could have any voltage. Okay, and when we click here, we can see it has around 4 volts. So that means this PNP transistor, actually if it has to turn on, we have to give a low here. So now as this is this particular transistor is floating, and this has a floating voltage here, and if you probe V out, you can see it is 26.8 millivolts. Okay, so now that meant there is no voltage here, and correspondingly there is no buzzer that is going to give out any sound, right? Very clear to understand, right? And then let us assume there is water on this particular sensor, and water has been sensed and the impedance reduced. Now let us reduce the impedance to 10 ohms, for example. Okay, once this is done, let us try to close the output window, and let us try to simulate again just to simplify the things. And what happens now, there is a huge current that flows into the base of this particular transistor. Okay, so generally in this case this might not be a feasible condition, right? So that's why you could add an additional resistor here to control the current that flows into the BJT, and allow only current which can turn on uh, the NPN transistor. Okay, so that is part of your design. Based on the sensor you select, you can do that. This is a sample circuit to help you, right? So now as you put 10 ohms, what is expected? There will be a sufficient current that flows into the base of this transistor, and this transistor should be turned on. When this Q1 transistor is turned on, that means this particular um, wire should be grounded, right? Or this particular connection should be grounded through the Q1, correct? So now let us try to probe the GC. You can see here the GC is almost zero. There is a negligible amount of voltage here. That could be because of the finite resistance here. Okay, and you can see it is 0.2 volt, which is negligible, right? Because there is the V base to emitter voltage, which actually will be developed, right? Now let us actually try to probe the output voltage. Okay, when we probe the output voltage, you can see here, which is the blue waveform, which has come almost nearer to the 5 volts. That means there is a voltage that is developed here, which means this particular transistor is on and the 5 volts is coming down through this transistor and being supplied to the load. And now as the 5 volts is here, there will be current flowing through this load, and this load will start functioning, whether it be buzzer. If it is a buzzer, it glows. If it is an LED, it glows. Or whatever you connect. So very simple, right? Now let us just, in the same scenario, let us try to give it back a resistance of 1 meg. Okay, and then let us try to simulate here. You can see here the blue waveform, which is V out. Okay, we named the node as V out here, has gone down to 0, and the gate voltage, actually, as this is floating, it has reached a high voltage. Because it's a floating voltage, we cannot say there is a leakage here. Okay, so as this Q1 is off because it doesn't have sufficient current. Now of this entire circuit, there are elements which we understood: the NPN PNP transistor, and then the resistor, which represents a load, and then there is a power supply. So there is a decoupling cap also that is added for this particular supply. Okay, in your circuit, based on the noise that is present, you can add whatever capacitor you want. And then there is this R and C. Okay, so R and C, what happens is, when there is a negligible amount of current that flows, or example, if you want to hold this Q1 in turn on condition, when the sensor is actually having low impedance, from this particular node there is a current that flows and keeps this Q1 turned on. That's the entire intention of the circuit. Still, without this R4 and C2, it works, but it is preferable to have this particular circuit. Very simple circuit, which can be implemented easily by hobbies, and it can be used in your home. right? Please provide your feedback on this circuit. Thank you.